guys, I've been having some technical difficulty today, so this is literally the third time I've recorded this video. Hi, welcome. We are continuing specific types of free response. AP exam is in less than 4 weeks, basically 4 weeks. And today we're doing free response questions with table stems. Lizzie just walked by. Okay. So for this one, we've got a table of WT, which is the temperature of water in a tub, as a function of time, which is measured in minutes. Part A is asking us to approximate or estimate W prime of 12. W prime would be finding the derivative, which is like the rate of change or the slope. Now, this is a table. I don't have like an exact function or a graph, so I can't get the exact derivative at 12, but I can find the slope between 9 and 15, and that will be a good approximation for at 12. So slope between 2 points is just your f of b minus f of a over b minus a. So this is going to be w of 15 minus w of 9 over 15 minus 9. W of 15 is 67.9. W of 9 is 61.8 over 15 minus 9. 15 minus 9 is 6. I went to my calculator. This is 6.1. No need to go anywhere any more simplified. That's good enough. Now, it also asked us to give the meaning of this in context of the problem. So I put some sentence stems on the top of the assignment. Derivatives are actually really, really easy to write a sentence for because all I have to say is this derivative represents the rate at which blank is changing in blank at t equals blank. So then now I just need to go through and plug in or like substitute in what these blanks are. So W prime represents the rate at which W, and then we just go to the problem. I obviously don't have this written in front of me. I don't know what I'm pointing at. But it said that W is the temperature of water in the tub. So W prime represents the rate at which W, the temperature of water in the tub, is changing in. Now we need to put our units. So the units are going to be the units of W divided by time, because that's what we're doing when we take the derivative, dW dt. So that's going to be degrees Fahrenheit per minute. And then we just put at what time. So at t equals 12 minutes. And there's our answer. B, we are also asked again to find the value and then give a sentence. So let's focus on the value. We're doing antiderivative. Now, if I were to find the antiderivative of W, that would be pretty hard, but I'm not. I'm asked to find the antiderivative of W prime, so then we look, oh, antiderivative of W prime, that would just give you W. Now, this is a definite integral, so I need to use these bounds. This is going to be W at 20 minus W at 0, that first fundamental theorem. Remember, fundamental theorem of calculus tells us that, which is basically what we did here, but with W. And then we use this. W of 20 is 71 minus W of 0, which is 55. So this is 16. So that's my answer. And now I need to give a sentence explaining the meaning of this in context, and I have to put my units. This one, for integrals, I can't give a general, just this sentence will always work the way I can with the derivative. I'm still going to say this represents blank in blank. So in blank. Now it's not at t, it's going to be from t equals to t equals, in this case 0 to 20 minutes. Let's talk about the meaning now. So we're finding the antiderivative of W prime. W prime is the rate the temperature of the water changes. If I have a rate and then I take the antiderivative, it's not a rate anymore, it's an amount. So this is going to be the amount that the temperature changes. So this is the amount, the temperature of the water changes. And the reason I have to put that changes is, think about, I'm not saying the temperature in the water is 16 from 0 to 20. I'm saying from 0 to 20, the temperature in the water changes by 16, right? We literally said the temperature at the end minus the temperature at the beginning. That is the change in the temperature. For units, you could literally just look at like what we did for our answer. See how we have 71 degrees Fahrenheit, W20, right, in degrees Fahrenheit, minus 55 degrees Fahrenheit. This answer has to be in degrees Fahrenheit. The other way to do it is look at this right here. We're multiplying W prime times dt. So the units of dt are units of time, right, minutes. And units of W prime, we said were degrees Fahrenheit per minute. That's what we did for W prime up here. And then look, we have per minute times minute. That cancels out and leaves me with just degrees Fahrenheit. Okay, and see, we're asked to calculate this. We don't need to give the meaning of it in context because it actually told us. So this, just a quick recall, is average value theorem. So this tells me the average value of W from t equals 0 to t equals 20 in the units of W. W here is the temperature, so this is the average value of the temperature in degrees Fahrenheit from t equals 0 to t equals 20. Again, don't need to write that because it gave it to us. I'm just practicing if you were asked to give that sentence. Alright, it said to use a left Riemann sum. So for left Riemann sum, we're going to go up to our table, break it up into the different intervals. So here I have 4 different intervals between these 5 points. And then we're going to be literally multiplying base times height, and left Riemann sum will use the left side, so starting with 55. So next one will be 57. This is a width of 5. Next one, width of 4, 61.8 is the left value. And next one, 67.9 with a width of 5. Now this is just the integral part, right? I'm adding up my Riemann sum to get the integral. I still need to put the 1 over 20 out front, because if I don't have the 1 over 20, that's not the average value. That's just, well, I don't even know what that would represent. It would be kind of meaningless. Alright, you may absolutely use a calculator. If you don't have a calculator, just use one on your browser. So add these all up. I get 12, 15.8. Make sure you divide the 120. Again, just use your calculator on the online. So then I get this. And remember, the meaning of this, or what it represents, is the average temperature of the water from 0 to 20 minutes. So then you look at your table, and you're like 55, 57, 61, 67, 71. Yeah, 60 point something. That definitely makes sense for this average temperature. Right? It says, asks, is this an under or over estimate? So in the stem of the question, it told me that W is always increasing, so I'm going to sketch just an increasing graph. Now I'm going to put 2 points. We did a left Riemann sum, so of these 2 points, I'm going to use the left one as the height. So this will be my height, like that. See how this area is going to be an underestimate of the real graph? So this is an underestimate because W of t is increasing. And definitely make sure you say it's W of t that's increasing. Don't say it increases. Don't say the graph or the table or the data. Tell me exactly what's increasing W of t. Alright, good luck guys. See you at office hours.